Hi, everyone. Welcome. Thanks for being here. Hope you had a nice lunch. I'm Justin Braaten, Developer Relations Engineer with the Google Earth Engine team.
I'm Qiusheng. I'm Associate Professor at the University of Tennessee.
Yeah, and we're here today to talk about extending Earth Engine's Python experience with Geemap.
Yeah.
And I just have to say that I'm really excited to be up here with Qiusheng. For the last few months, Qiusheng, Nate Schmitz, and I have been meeting weekly over video chat, and so it's really great to be up here with you now. So today we're going to talk about what is Earth Engine, the Earth Engine client libraries, using Geemap as a Python IDE. We'll take a Geemap tour, so hit the highlight features, and then do a live demo of working with Geemap. And then we'll do a question and answer session. So I'm just curious, who all here uses Earth Engine already? If you raise your hands, looks like most people. How about, are there any Earth Engine code editor exclusive users? You don't work with Python at all. How about Python exclusive users? All right. So I'll just do a little overview of Earth Engine. It sounds like you must know about it, but just for completeness. So Earth Engine is Google's cloud-based platform for geospatial analysis, for visualizing data, and doing analysis at sort of global scales. And it's got three components: a data catalog that's co-located with Google size compute power, and you can access these things with the API. And the data catalog, I think there's over 1,000 data sets now. Many of them are streaming, and by streaming I mean that these sensors are collecting imagery all the time, and we are getting them from the provider almost as fast as they are processing them, and we make them available. And when you're working with Earth Engine, you're working with the API. This is the instructions that you write to tell Earth Engine servers what to do with the data and what you want to get back. And so you write instructions. Here, for instance, I have a function that says Earth Engine do a thing. So I've described some process that I want Earth Engine to do. And the client library packages up those instructions into an expression graph, something that Earth Engine servers understand. And it uses this web REST API to transfer these instructions to the Earth Engine servers. The task might get split up among many servers, and then when they're completed, they'll be put back together. And however I requested the information back, maybe map tiles, or some object that I want to print some information about, that reduction of my analysis gets sent back to the client, and I can do what I like with it. And we have two primary interfaces to Earth Engine. We have the JavaScript code editor. We could also program with Node.js, but the code editor is a really popular interface. So we have the JavaScript code editor, and then we have the Python API. And they share almost exactly the same Earth Engine language. And so Earth Engine, it's object-oriented. We have this set of classes, and these classes have methods. So here, for example, we have an Earth Engine image, an image collection, and a feature. And these represent different kinds of data. And each data type has a specific set of methods, and these are the things that you can do with these data. And whether you're working with Python or JavaScript, this Earth Engine language is the same. The differences in syntax come in how you declare a variable or a function, how you are doing a for loop client side. But typically 90 to 95% of the code that you're writing is probably Earth Engine, and it's a shared kind of syntax. So we have this language for you to express what you would like Earth Engine to do, but we need a way for you a place for you to write this script and to explore the results of your requests. The map tiles, you want to view the map tiles, or you want to print an object, get some properties from a feature collection. And this is the interactive development environment. And so we have, with the JavaScript API, we have the code editor, and this is a project that the Earth Engine team has been working on for 10 years or more. And so it's very feature-rich, it is very convenient, there's been a lot of thought put into it. But for the Python API, it hasn't had that kind of attention. And so they really made me think of this meme where the Earth Engine team is paying a lot of attention to the code editor, and meanwhile the Python experience, people are sort of drowning. And so this is the code editor, and it has these really nice features. There's a lot of integration of useful tools and help. And we have docs that are integrated right into it. You can save your scripts. You can share your scripts. You can look at your assets. You can manage tasks. You have nicely printed objects in the console. The map is very integrated and convenient. And you don't get any of these things with the Python API. You're expected to do these things that you need on your own. But there's a lot of reasons that you might want to use Python. A big one is automation. So if you're working in the code editor and you start a task, there's a lot of user interface button clicking to get the task to run. Also, if you're ingesting data, you're uploading data, again, there's a UI for doing that, and so there's a lot of button clicking. And so some of these tasks would be really nice to use Python to automate exports and upload data. Also in the code editor, it's a sandbox. What you see is what you get. You can't bring in any external libraries into it. And within the Python ecosystem, of course, there are a lot of really useful libraries for doing data analysis, machine learning, and visualization. And there's also a lot of cloud services that are helpful. And with Earth Engine being more connected to Google Cloud, it's nice to be able to take advantage of these services. And with Python, you also get development tools, things like GitHub. You can create a script repo and collaborate with people on an analysis. You can package that repo up and deploy it as a Python package for others to install and use. There's continuous integration, continuous deployment tools, testing frameworks, and these things that you don't get in the code editor. And so there's a lot of reasons you might want to use Python, but it's challenging when you don't have an interface to interact with your data that you're requesting. And so Qiusheng in 2020 has provided a great solution for this with Geemap, which is it's a Python package that you can use in notebook environments, and it includes a map display, rich object printing, and a lot of helper functions. And it's really made it possible for the Python community to have a similar experience to what code editors have. And so here's just a timeline, a little bit of how Geemap has come to be. But what's missing from this is quite a long time before this of Tyler Erickson trying to get a Python solution going. And I think there were a lot of challenges around how to do this. The technologies weren't quite ready yet. I think about Colab, not supporting custom widgets for a long time was a hindrance. We could work with Jupyter Lab and Jupyter notebooks locally, but it's a lot of extra setup steps that it's hard to have somebody that uses the code editor to convince them to use an environment where there's so much setup and maintenance. And so nothing ever felt like it quite fit right. But developments with Colab allowing IPy leaflet or custom widgets in 2021, I think was a real game changer. It made it possible to include a map interface that had interactivity. And so we wanted to sort of replicate this code editor experience for people, and searching for a solution to do that, and a way to include examples in our developer guide, something that would be easy for people to execute, that they didn't have to maintain their own environments. And so we thought, well, Colab is working really well now. We can have a map, and Qiusheng has Geemap, which shares a lot of the functionality that we're looking for with parity with the code editor. So we approached Qiusheng earlier this year and asked if we could partner up with him to create a core module within Geemap. And the core module would have sort of the basic functionality that you need to explore and interact with your requests. So that includes the map interface, being able to inspect, being able to draw, a layer manager, printing objects, these really basic features for being able to explore your analysis. So with the help of the Earth Engine front-end team and Qiusheng, this Geemap core module has now been implemented, and we have integrated it into our docs. So most of the places in the in the API reference docs where you see a JavaScript example, there'll now be a tab where you can switch over and see the Python example. And anytime an object is displayed or a map tile is shown, we're using Geemap. And this is really exciting. Geemap is now pre-installed in Colab. And so it just removes one more barrier to sort of entry. You don't have to pip install it anymore. So Qiusheng, will you come up and talk a little bit about the features of Geemap and give us a demo?
Thank you. How's everyone? Awesome, right? Yeah, thank you. So Justin gave a great introduction to the kind of journey that we have been going through during the last couple of years, kind of trying to enhance the Python experiences. But first, before I go into Geemap, I'd like to acknowledge the Earth Engine team, building the great product that we all benefit from. Without Earth Engine, I don't know where I can spend my free time. I don't know, I don't have nothing to do. But so the next section, I'm going to show you some of the key features, what Geemap is about, what kind of things you can do with you, and we'll give you some demos, videos, and at the end we'll show you some kind of live demo. So Geemap is open source. You can check it on GitHub, and you can see some of the key dependencies. So basically, Geemap is trying to enhance the visualization and also make the analysis a bit easier. So just to quickly maybe ask, how many of you attended the workshop on Monday? Okay, a couple of those, right? That's great. And if you attended, you know my slogan, it's what? One line of code. Okay, so one line of code. So we make it so much easier for you to do a lot of things within Python. And also, I would like to acknowledge Tyler Erickson is also here. A lot of work that was inspired by him earlier when I watched the video, and then he gave before that actually inspired me to do that. Oh, now it's feasible to do that using Python, using IPy or Folium. So thank you to him. And so key dependency, for example, Earth Engine API, and then IPy, Folium. So basically, those are the open source mapping libraries that allow us to visualize the Earth Engine data interactively. And also IPy widgets. This is where actually Geemap is about, is to a lot of widgets allow you to interact with the data without having to write code. So IPy widget is also a major component in Geemap. And eWrapper is basically to allow you to display objects, rich representation, so they can have similar experiences like the JavaScript API, and also Plotly, bqplot for doing plotting. And for the Geemap, if you want to learn more about that, you can check out the geemap.org website. It's very easy to remember. So all the documentation, tutorial, API, references, installation, you can find all the things in there. And if you are interested in learning more, you can look at the function, look at the documentation. So there's kind of the way to get started, and also have a lot of tutorial, workshop. I've been giving a lot of workshop in the past, so you can actually also, all the workshops are mostly being recorded. So also the Monday, this Monday, the workshop also being recorded, so you can check the video later. And I also published a short paper describing what Geemap is about. This one was like in 2020. It's very rare for a software paper to get like citations, but you can see like actually people are using it, and then you can see like over like 100 citations. I've never imagined like, oh, I'm just going to publish this, and then it gets more citation than my scientific journal publications, like I do research. So I say, okay, now I can do software. I don't need to spend too much time on doing like this. Is also has an impact. So I laugh, like if you find it useful, you're welcome to cite the paper. I thank you for getting more citations. And here I'm going to show you some of the statistics. So Geemap started in March 8, 2020. So the first release on PyPI. And you can see it's roughly right after pandemic, 1 month after pandemic. So at the time, I was teaching my students how to use Google Earth Engine and how to use Python. I'm kind of very exclusively using Python. And it was a big challenge at the time because if you're early user, you know you can only print out a thumbnail of the image. You cannot really read the data interactively. And then so from Tyler Erickson, I saw some tutorial, and then I figured, oh, you can use mapping libraries to pull in the tight data layers, and then you can visualize that. And then I kind of, okay, I want to make this for my students, but how to publish it? I have to put it on GitHub, and then I push it there, and then the rest is history. People like it, and then I continue to add features every day, and not every day, every week, but every week or two, I release a new version, add some new features, and then I develop it, and then I teach my students in class next day that the feature is available, you can do this and do that. And so far, it has achieved 3 million pip downloads and over 200K conduct installations, and have given over 10 workshops and 137 novel examples. So on average, not right now, the GitHub page is being visited by over 1,000 times. Not 1,000 users, but a couple, like maybe 300 or 400 users every day. And it's being used by, the website being visited by over 100K users from 208 countries. Probably not all the users like Earth Engine users, but the website is being visited by a lot of people during the last couple of years. And so we were lucky to have some funding from NASA. So NASA has the open source initiative that fund some of these open source projects. And you can see Geemap is among NumPy and GeoPandas. So we are very proud to be part of the team to have funding support for 2 years to help develop and maintain the package. Also, I published a book because I have so many notebook tutorials, like 137. So the publisher reached out to me that, oh, we want to publish a book on Earth Engine. Can you like put things together? Okay, yeah, I already have a lot of code snippets, but I just need to write all the description and the figures and other stuff. So I put it all. It took me almost a year to put it all together, but it's open source, open access, so you can upload the link there. You can check out the book. So it gives you a very comprehensive introduction to Geemap and how to do interactive mapping and also analysis. If you want a hard copy or a PDF copy, you can check out the link on the publisher website. But it's free and open access. You don't have to buy. You just spend some time, click the notebook, and then you can just run through it. You will understand it. And I also create a lot of tutorials. So you can check out my YouTube channel you're interested in. And so far, I published over 600 videos. I don't know what's the total length, and with over 26,000 subscribers. And I think over 1 million views. So right now, daily I get like 70 to 100 hours, watch hours that people actually are watching the videos. So not just Earth Engine, I also do a lot of other open source. So if you're interested in, you can follow the YouTube channel. So next, I'm going to quickly talk about what we have been working on the last couple months is to create the so-called core and also the extra features. So the idea is this, Geemap has a lot of functionality, and the Earth Engine team cannot support everything, right? So there are some of the random features that not everyone is using, but there's some core functionality that we want to provide similar to the JavaScript co-editor. So I work with the Earth Engine team, including Justin, Nate is there, and Sufyan, Ben, and Jorge. They are fantastic. So they kind of bring Geemap to the whole another level. So on the surface, it's still the same. You still import Geemap, nothing changed. But under the hood, there are a lot of reorganization and also improvement. So now it's so much better. And it's also already on the Earth Engine documentation. The only difference is import gmap.core as Geemap, but you can just use it as you traditionally use as import Geemap is the same. But this makes it easier for the Earth Engine team to maintain because we want the core features to be stable so people can, we don't break things all the time. And so for today, I'm going to show you like just 5 key features that makes it so much easier for you to interact with the data. So also there's a code snippet in the lower right corner there. So it's very simple, kind of exactly the similar experiences like how you use the JavaScript co-editor. So you create a map, you add some data layers, and then you display the map. And after that, you can do analysis, you can change the visualization, you can do all kinds of things. There's also a base there, open on Google Colab. So now Geemap has been pre-installed in Google Colab, so you don't need to install. You just click and open, and then you can run through this code. And any of those code examples on the documentation, you can do that as well. So it's so much easier. And thank you, Justin, and also the Colab team for adopting that and then include it in the Colab environment. So here are a couple of features I want to show you: base map selector, layer manager, layer editor, and inspector, and also draw control. So those are kind of key things when you are trying to interact with data. We want to be able to do that. So next, let's play the video. The first video is about interactive map, right? Base map. So allows you to select hundreds of base map. And it's just one click, there's no coding. So my slogan is one line of code. This one is even no code, just like select. And this one is based on the XYZ services. So you have hundreds of base map available. And I have a lot of demo to show you, but I want to encourage you to think about if you're already the JavaScript users and think about some of the features, how many lines of code you need to write if I want to implement this feature. And I will sometimes mention, for example, this one is not available on the JavaScript code editor. So you are limited to the Google base map, but sometimes if you have some other base map, this one is, makes it so much easier. So you can select from hundreds of base map available, or you can add any XYZ tile layer or WMS data layer. So it's so much more flexible. Next video. So this one shows you how to manage the data layer. So you can turn the layer on and off. You can toggle it on and off. You can change the opacity interactively. So it's very simple to use, and you can also hide the toolbar. So this is very much similar to the JavaScript code editor and similar experiences. Next video. This one is about changing the visualization. So the Earth Engine, basically, you need to have some coding to be able to change. And so the Geemap makes it so much easier. So you just add the data layer, then you can change the opacity, you can change the band combination, you can change the visualization, similar to the desktop GIS, right? Open the property and you can change. So not just for the raster data, you can also do it for vector data. So in this case, you can change the outline, the fill color, and you can also preview it. Essentially, it's getting all the parameters sent to the Earth Engine, and then retrieve the data layer back, and then you can just visualize it, right? So there's no coding. It's very easy. You can also click the there's an import button. So if you click the import button, it will show you the code, the snippet. And then if you want to do that programmatically, then you just copy the snippet and then put it into the code. So that in that way, you don't have to use the interactive GUI. So everything that I'm showing here, under the hood, there are some code executing to do that. So it's very flexible. You can do it either using the interface, or you can just use some coding. Next video. This one shows you the so-called inspector, right? So if you're using the JavaScript code editor, you probably are familiar with. So most of the time, if you're doing remote sensing, we want to check the spectral signature, or you want to check the value, the pixel value, or the feature collection, or the geometry. So basically, just one click, and you can get the information, whether it's a raster, vector, and it's so much easier. This looks very simple, but under the hood, there's like hundreds of lines of code to make this actually work, because it's not the data not on your computer. So it's like getting your coordinates and then do the computation, send the result back, and then display it on the map. Next video. This one is called using the draw control. So allows you to interactively create geometry objects. So this is an Earth Engine object. Similar to you using a JavaScript code editor, you can create and then you can modify, and then you can use that to do computation. So for example, if you're doing a specific area, you have already have some geometry. You want to clip the global image to a specific area, you can do it easily. So everything is interactive, so you can, whatever you draw on the map, that object can be saved as a variable, and then you can use that to pass into other programs. So this is basically bi-directional, not like one way, get the data and then display the map. So it's very, very powerful based on IPy leaflet and IPy widget. Okay, so let's go back to the slide deck, and I can show you here. So those are the core features. Basically, the Earth Engine team help develop and also maintain. But there are a lot of like extra features that I'm going to show you. So today I will give you a quick overview of some of these features. And I think we have 11 here. But keep in mind, so I have 137 notebook examples. It's more than 170 features. So what we are showing here is less than 10% of the features. So you're welcome to check out the website. But I want to show you some of these highlights that might be useful for you. And as I mentioned, import Geemap.co as Geemap or import Geemap. So you can just import Geemap. You can use all the features and all the dependencies. And then everything else remain the same. So the first one is about converting Earth Engine JavaScript to Python. So if you're already JavaScript users, you want to try out Python, but you don't know how to do that, this might be very helpful. Just not even one line of code, just no code. Just click the button and it can change. If you have a bunch of script already on your computer, you can just call the function. You can automatically convert whatever script that you have. But keep that in mind, it's not bulletproof. It's, if it's very complicated script, you might need to modify it manually after you do the conversion. So let's roll the video to take a look at what it looks like. So there's basically the widget allow you to click. And so just click the button, paste whatever JavaScript code that you have, and then you're going to generate the code block, and then you just run, and boom, the data is in. So this can save you a lot of time, like trying to think about the syntax difference between, so for example, just copy from the documentation, and then convert, and then run it, then the data will be in. So it's automatic conversion. Of course, the documentation has been improving the last year or two, adding more and more Python examples. But for some of those that the Earth Engine team has not converted yet, you can just copy, paste, and then run. It should just work. Like I said, if it doesn't work, just like look at the code and then fix it. But it at least save you time that you don't have to go through line by line how to convert the JavaScript to Python. Next video. So this one is about searching data. So earlier there's a section about data catalog. So we have over 90 petabyte data. It would be nice just type the keyword and then search, and then there's a code example automatically convert from JavaScript to Python, and then you can just load the data and select whatever data you want and then visualize that. So there's like very minimum. So there's no coding in here. It's just like click the button and then execute it, and then you get the data. For example, this is a US state boundary and also the ESA global land cover. You can see it's so easy. There's no we lowered the barrier so that now you can try out anything. So this is very powerful. Think about like you have access to over 90 petabyte of data, and it's all at your fingertips. All you need is just to figure out, oh, what data do I need? What's the keyword? And then just search it, and then you can just visualize it. Kind of like you have access to the entire Netflix database, but it's free. You can watch any movie you like, action movie, romantic movie, whatever. The data are there. So now you see I don't have to I just have an account, log in, click, and then create a map, and then search, visualize that, and then can do analysis. So we are only talking about visualization. Analysis is also like a whole lot more that you can do with Earth Engine. Next video. So this one is about creating Colorbar, for example. So if you have elevation, you have temperature. Sometimes you might have to wear the Colorbar to indicate like the temperature range or something like that. So you can make it horizontal, you can make it vertical, you can also make it transparent. So again, this is just one line of code using the Geemap. If a JavaScript users, think about how many lines of code you need to write to create a Colorbar. So they take more than one line of code. Next video. This one is about the plotting. So sometimes if you want to see the spectral signature, you just click the button, load the data layer, click the button, and then it can be multispectral data. You can, for example, hyperspectral data. And everything that you click on the map, you can also easily save the results. So this might be useful if you are doing like machine learning, you're trying to like create some training data, and you want to like do that interactively. This also allows you to do it. So under hood, you're using BQ plot and also plot this. So we'll improve this in the future, but for now, at least allows you to see the spectral signature very nicely without having to do that. But if you want to do that using JavaScript, like you need to use a reducer, you need to put things together. So it's not like one line of code, but now Geemap, you can do that without coding. Next video. This one is about visualizing time series data. So you can see there's a time slider at the bottom right. So if you're trying to visualize data, for example, this is vegetation every day, right? We have 30 days, or you can visualize temperature every hour. It doesn't matter. So your image collection can be 100, 200, it doesn't matter. So you're going to create this time slider that allows you to interactively select the data layer you want and then visualize that without having to add all the data layers to the layer manager, because you don't want to add like 100 layers all to the layer manager. It's going to be very slow, but this one at least gives you some way to visualize, and you can just change the date you want. And you can also play just like an animation, but there's a time lag because it's pulling the data layer from Google Sensing and then display it, but sometimes internet slow, it might not very smooth, but it's better than just loading all the data layers to the map all at once. Next video. This one is about like time series inspector. So basically allows you to visualize different data layers side by side. So in this case, we are showing you how to visualize a lane cover database, right? So you can select on the left, select another year on the right, and then you can just compare and then use the slider. So it's very easy. This is also just one line of code. So think about how many lines you need to do using the JavaScript. It's a bit more complicated than the Python version. And you can also add, for example, the legend right on the right. And you have built-in legend. You can one line of code. You can load the legend to the map as well. Next video. This one is kind of similar, but allows you, for example, to create global lane cover, for example. Just one line of code. If you want like a dynamic world data set or European space ESA global world cover, you can just one line put the data in, and then you can compare side by side. You can have access to all the data layers, the lane cover, the probability. You can create a time series. So for example, I'm interested in lane cover change of a specific area every quarter or every year. Just one line of code, specify the location you want, the data you want, the temporal frequency you want, and then you can pull the data. Visualization is very easy, and also you can have the legend, you can show it on the map. So it's kind of a nice feature if you want to do some lane cover change. Next video. This one is about integration with desktop.js. So if this one is ArcGIS Pro. So for those of you who are familiar with desktop.js, we have QGIS, we have ArcGIS Pro, and again, I developed the QGIS plugin that allows you to integrate this. So I also created the ArcGIS Pro. So now ArcGIS Pro plugin, so allows you to run the notebook side by side. So you can run the notebook using Geemap, whatever code you write, and all the data layer that you add to the layer can be pulled into the desktop.js. So in that way, you can utilize the base of two worlds, right? Because Google is great for computation and then for visualization, but when you come to like create high quality maps, I believe most of you are still taking a screenshot, right? Sometimes not the DPI is not high enough, or you need to export the data to your computer in order to create a map in other desktop.js. But now you don't have to do that, so you can just run the code and then the data layer will be pulling. Then you can use those desktop.js to create high quality maps. And so it's basically pulling as a base map to the data layer. So in that way, you can do some, create a map to whatever layout you want, and you can add different components. So in this way, you can create much more high quality maps than just taking a screenshot. So it's, again, this is ArcGIS, but you can also look online for the QGIS plugin. Next video. And if you're very specific about like projection, so Geemap also has the Kato-E module, actually contributed by Kale, but he's a Google now. But you can see you can create any projection, custom projection you like, not just the web marketer. So there are lots of options you can choose from. Especially if you're doing like polar region, you can create like polar projection. So allows you to run all the analysis in Google Sensing and also in Geemap for visualization. But when you're ready, you can pull the computed data layer out and it can plug in using under the hood using CamelPy. So this also is very useful, especially for academic publications. Sometimes you need a very specific projection, and this one can help you. Next video. So this one is about creating animation. So during the workshop on Monday, I show you how to like create animations in just one line of code for lane set or any image collection in Google Sensing. But Geemap also has a button that allows you to basically zoom to anywhere you like and then just draw a rectangle and then just click a couple buttons and then you can create the animation using the lane set time series since 1984, right? So we have every year, so we have almost 4 TB of data. And there's no coding. Of course, you need to create a map, like import Geemap, and after that, you just click the button and you can change it. So this is so powerful and it's so much easier. Before Google Sensing, right, you have to go to USGS, you need to search the data for the area, and then you download a bunch of data. And the data sometimes are not good, right? You have cloud issues. You need to deal with the cloud problem, and then how do you mosaic them, and then how to create like annual images. And how to add, for example, labels on the map. And also, Google Sensing or the Google Earth has the time-lapse, like products, global scale. But that one is only RGB only. So sometimes you're looking at vegetation, you want to highlight specific feature using different band combination. This might help you because you can choose any combination you like. And you can zoom to anywhere, so you can, it's much more flexible and customizable. So next time if you go online, like see some people post on social media about this time lapse, now you know, okay, one line of code. Oh, no coding, right? Geemap, just create the interface and then anywhere. So right now the interface shows you how to create that using lane set, but like I said, you can do any image collection as long as you know the ID, and then you can just pass in and then just figure out, oh, I want the by year, I want by month or by quarter. But of course, the data needs to support it. But if the data can do daily, then you can just specify and then just create time lapse. And then you can choose the area, choose the color, all kinds of things you can customize. Again, no coding, so it's easy. Everyone can do it. Next video. And this is the last video I'm going to show you. This is about the so-called interactive web app. So if you create some data products, you want to share it with other people. So Google Sensing has the Earth Engine apps. It's the JavaScript version, right? You can turn your data into product, but Python is not that straightforward, but there's recently a package called Solara that allows you to basically turn your Jupyter notebook code and then into web version. And this is deployed, for example, on Hugging Face, right? So everything that I showed you earlier in some of the demo, I can deploy to the web. and then you just send the link to anyone, they will be able to just open the link, and then you can interact with the map. So this makes it so much easier because you can make your data more accessible to people without a Google Sensing account, right? Or they don't have the coding background. So you can, if you're publishing a paper or you are working on a project, but you want to make it accessible to other people, this might be something you might be interested in. You can either just take your notebook and then use Voila and then deploy, for example, to Hugging Face or whatever cloud environment that you like. All you need is just go to the repo, click the link, duplicate, and then set your Earth Engine token, and then it should be up and running within 2 minutes. So you can create an Earth Engine web app within 2 minutes. Then you just customize it, add the data layer to whatever data layer you're interested in, and then you can also, for example, if you want more complicated interface, you can use IPy widget to create those like input box or drop down list or whatever, and then allow user to interact. So if you already know JavaScript, perfect, like use JavaScript app to develop. But this is more like for those users that don't have JavaScript background, don't know how to design the user interface, Python is so easy. It's just like, as long as you know how to run the notebook and how to write the code and then execute, join the map, then all the code pretty much is the same, and just convert it and then put it inside a function, and then you'll be doing it. You can check out the source code. Everything is open source, so you can just replicate, and you can do that for your own application, your own data, your own specific area. And like I said, it's all free. There's nothing you need to pay. Nice thing about this is that the computation is supported by Google Sensing. And then, so the front end is using this Solara package. But you can deploy using a free cloud computing environment, so you don't need to pay anything, but you can make your work much more accessible to everyone around the globe. Okay, so that's all the video demo I want to show you. Like I said, this is only like maybe 5 to 10% of what Geemap, the feature that Geemap has. You're welcome to check out the website, and if you want to watch it, you can access the PowerPoint. So let's get back to the slide deck, and I want to give you kind of a live demo, what kind of thing, how to get started. So if you are totally new to the Python API or Geemap, I have the notebook example here that can help you get started. It's very easy. Like I said, you just need an account, and all you need to know is how to click the buttons. There's no, like you have to write code. Of course you can, but it will be very easy. So I'm going to give you a live demo quickly to go through some of the core features. And okay, so let's switch to my screen here. And so I'm going to go through the link, or you can just, let me show you here how to get access. So I can go to the Geemap website, and all the notebook examples are available in here. So if you click notebooks, there are also workshops, for example, the G4G 2023, so the workshop they gave on Monday, all the source codes are here. So you're welcome to just click the link. If we have time, I will quickly go through that, but for now I want to show you the core features. So if you go to notebooks, and then the first one, Geemap Colab, right? So you open, and so this is basically what some of the core features I showed you earlier in the slides. And all you need to do is just open in Colab, so just right click, open. Right, so as I mentioned, Geemap now is pre-installed, so you don't actually have to install. But sometimes it might take a week or two for them to install the latest version. So if you are, we are developing very quickly, if some of the new features are not available yet, you can just install the latest version. So I can quickly show you here. The first line, you can just control / and then just run it. So basically here we are updating the Geemap package to the latest version. And so right now in Google Colab, it's 0.28.2. We just updated over the weekend, so it's like the latest one is 0.29. So it should be, like I said, just click the button and then click the run button and then they execute. It should take 10-20 seconds, and once it's done, then it's available, so you can just run through it. So I'm going to clear the output here. Okay, so in order to use Google Sensing, the first step is to import IDE, right? So this is the Earth Engine Python library. And you see this one is already installed, so it's there. And the next one is Authenticate, so make sure that it's coming from you. And right now you need to click a few buttons, but I hope that it will be easier in the future. For now, just click this one. And if you're new users, you might need to create a cloud project. It's free, you don't need to pay anything, but it's use that to do authentication. And then just click generate token. And it takes a couple seconds, you just log into your account. And then click one button, allow access to your account. Then you should generate a token here, authorization token. And then just copy the token. And then pass it back to, this one here. Passing to input box, Control V, hit enter. And you should see successfully saved authorization token. So that means right now you're authenticated. I know this is a bit more inconvenient compared to JavaScript code editor, just open and I can do, but Python, this is what it has now. But hopefully in the future it'll be easier. So the next step is to initialize. So you authenticate and then initialize, make sure that you're not abusing the resources, right? So you make sure that you are you need to initialize this section. So right now we are using that, so we are initialize Earth Engine, and that's it. So now Earth Engine basically is available for use, but in order to use Geemap to all the interactive features, we want to either import Geemap.core as Geemap, or you can just import Geemap, right? Either way is fine, but for all the documentation on Earth Engine, you'll be using like import G-core. So I can quickly show you on the Earth Engine documentation, for example, here. And now if you go through the user guide, I can click, for example, image, and then image visualization. For example, here, you can scroll down. At the top here, there's a Colab. So you can open in Colab and you can run through that. Or if you want the specific, for example, here, you have JavaScript, the code editor, or you can also have Python, right? And so this actually has been updated to use Geemap. There's at the top, there's a arrow here. If you click Python setup, it's going to show you import IDE, import Geemap.core as Geemap. So this is where I showed you earlier in the Colab notebook. But again, you can just import Geemap. And then, so all you need to just copy the code block and then paste here. Then it should just work, okay? So I'm going to import Geemap.core. The first one here is called base map selector. So like I showed you in the demo. So right now it's more like live demo, right? So once you create a map, by default, it's using the OpenStreetMap. And upper right corner here, right, you can see all the base map available. So you can choose any one you like. So I can do, for example, CartoDB, for example, right? And or maybe what else? Or Esri war imagery, right? Base map. So if you want to access some of those, and this makes it so much more accessible because there are tons of base map data layer people make available around the globe, and it allows you to bring in any data layer you like, as long as you're using XYZ tile layer or using WMS. And there's especially if it is already available through the XYZ services packages, and then you can do that. For example, you can also do USGS topo map, for example, right? And the national map by the USGS has tons of those base maps. So now you can just pull in different data layers, and then you can overlay Earth Engine data layer on top of the base map without having to write code. So this one is pretty much no coding. The next one I want to show you is called Layer Manager. So all the examples are pretty much similar. So create a map, add the data layer, point to the data, and then specify the visualization parameters you want. And then just here we use map.add layer manager. So by default, it's going to show up here on the right. So this allows you, for example, to turn the layer on and off. And then you can take a look at this. If you use it locally, it's even more responsive. Google Colab is, this one, it takes a second like to turn it off, but you can also change the layer opacity. So I can just move the slider. Right, it becomes a little bit transparent. So kind of similar to the JavaScript code editor. And one thing that you might want to try out is here, for example, for visualization here, for the color palette, right? The color map, you can provide a list of hex color codes, but you can actually use any color map supported by Matplotlib. So for those Python users, you only know Matplotlib, this might be so much easier. So this is not something JavaScript core editor can do, but I can, for example, okay, I know this is a DM, I can just like single quotes and then just type, for example, terrain, right? There are tons of like color map available. I will show you more examples later using the layer visualization, but I just want to quickly point out that you can just, all you need is just remember like what's the color map, Matplotlib color map. Now I can, right? It's a terrain. I just use it to visualize the DM, right? There are so many color maps available. So this is the second one, and the third one is the inspector, right? So I can load different Earth Engine object data layers. It can be image, it can be image collection, it can be feature collection. So in this case, I loaded 2 data layers, a landscape data layer and also a feature collection. So by default, you see the inspector showing up on the upper right, and then you can just hover your mouse on the map and just click. It should be able to inspect. So I should point out that it looks a little bit slow. If you do it locally, it should be faster. I think it's just a Google Colab issue. But if you click anywhere, you can inspect, for example, the pixel values, and also if you just want one data layer, I can turn other data layer off, and then you should just do that for one layer. So I can click here, right? I can turn the raster off, and also behind there's also a DM, right? So I can just, if you just want a specific data layer, then you just turn other data layer off, then you should just inspect that data layer. And so here we have a raster data layer, also a vector data layer. If you just want, like, for the vector data layer, you might want to check the checkboxes upper right saying object. So in that way, I don't have to click the plus sign all the time to see the attribute. So for example, if exploring the data set, you want to see what kind of attribute it has, you just activate it, and then you can hover your mouse to anywhere, just click. Then it should show you, for example, all the attributes, the vector data intersecting with this one, right? So you can see here is California. Just give you a way for you to explore data without me to write any line of code. So this is for the inspector. So the next one is about the layer editor. So allows you to visualize the Earth Engine data layer interactively without coding. So in this case, I'm loading a raster data layer, and then I loaded the layer manager. So you can see here, we are previewing this data layer. And so this is what I was talking about earlier. You can use any Matplotlib color map. So all we need is just a name, right? So right now, I can just scroll down anywhere. Again, this is something not available in the JavaScript core editor, but we have integrated in the Geemap. So I can, for example, scroll down. I know this is terrain user is pretty good for visualizing DM data, right? And then you can see the Colorbar preview here, and then you can just hit apply. Then within a second or two, you should see the updated data layer. And you can also, for example, I can change to pretty much anything. So all you need is just figure out what name do you like. So I can choose maybe, how about cool warm, for example, and then just apply. And you can also specify how many classes, right? So by default, they are like the list of hex color code might be 255, but you can change it if you want a specific number of classes. And then you can also click the import button. It will show you the parameters at the bottom. Basically, you click, and then you can at least copy this one, and you can paste it into a code so that you don't have to click the button anymore. So this allows you to basically explore the data and then generate the code automatically, and then you can just run the code so that you don't have to click the buttons. So thank you, Nate Smith, for kind of refactoring. So it's so much better than the initial version in Geemap. And so that's for a single band raster, but you can also do that for multi-spectral band. So as I saw in the video, right, I give you a landscape imagery, and you want to see the this is the first color composite, but you can change to any band combination you like. So I can do, for example, B5, B4, B3, and then hit apply. Right? You will be able to see it changes, right? So you don't need to do the coding. You can also change to other parameter available through the Earth Engine visualization. So this makes it so much easier, just like providing a similar experiences, just like the desktop GIS, right? So open the data layer, I want to manipulate, I want to change something. Yeah, it's doable in the Geemap, and similarly, I think I can click the import button. And then at the bottom here, it's going to show you the code block. Like when I click the button apply, what's like the parameters used to do the visualization. And besides raster, you can also do vector data. So here, I'm loading a US states boundary, right? So, and by default, it's going to be black color, half transparent, or something like this. So if you want to change it easily, you can do that as well. And this is where beginners might have problem, because visualization like vector data is a bit different from raster. You need to use the style, or you need to use the pen function. When I originally started, I struggled like how to actually figure this out, but now it's so much easier. So you can just load the data without specifying anything. So all you need is just like a curly brackets. Assume that you don't know how to visualize that. You just add the data layer, use the default empty brackets, and then from here I can just, for example, I want to change the color to red color outline, and I want to change maybe the fill color to maybe, how about blue color, right? And then just click apply. It should change it, the visualization to whatever you want. If you want to be, for example, no fill color, just transparent, I can just slide back in, click apply, and then it should be just one line. So you can change all the data. It's supposed to be just the outline. Oh, because I need to open the data layer, so maybe here. So if it doesn't work, don't panic. You can turn this one off. You can turn the original one back on. And from here, I just click this again. It should pull up the dialog. And then from here, for example, I change it to red color, and I want to change it no fill color, and then just hit apply. Then you can just get the outline of the visualization. Last one I will show you is the dual control. So basically allows you to interact with the map so that you can create some object or feature collection to do some analysis. So here, this is, for example, the DM, right? So assume that you don't need the global DM, I just want a small subset. Then you can zoom to anywhere you like, right? And then so you can use the inspector and just draw whatever you like, a rectangle, polygon, whatever you name it. And then this one, you can access it through, for example, is a geometry. So basically, Earth Engine geometry. So it's basically saved in the map dual control object, right? So you can see, you can get the coordinates. Basically, everything that you interact with the map is some of those actually you can retrieve it later. So you can do, for example, you can access e-feature, or you can also do like feature collection. And once you have access to that polygon, you can just use to clip. So the last code block here is showing you, okay, if that object is not empty, I'm going to DM clip to that collection. So, and you can see what the output looks like. So here, I'm click to this imagery, and then I'm hiding the global data layer, and then now just showing you the clip data layer, right? So it's very interactive. There's only a couple lines of code, so it's very easy. And I can, for example, just remove the data layer. So now I only have one data layer, the clip DM. Oops. And the global DM and also the clip DM. It might take a couple like second or two. If you do it locally, it should be a lot more smooth. So I recommend, if you are really into Python, you can just install it on a local computer. Again, you can check out the all the installation instruction on the Geemap website. And then, so for example, go here, and then upper right corner here, there's a download button. And then you can download any notebook from the Geemap website, and then save it to a computer, and then just open it using Jupyter Lab. Then you can just go from there, you can play with it. You will not break it, okay? You can just do whatever things you want. And then once you're familiar with the step, it's pretty much similar. So create a map, add some data layers, and then display the map, do some analysis, and then add it to the map, and then you can continue. So you can iterate through. And it's very, very powerful because if you have the notebook on a computer, if you set it up, you can interact data with your computer. So for example, you have some small shape file, polygon or geostation, you want to use that as an ROI to clip the data, right? In JavaScript code editor, you have to upload the data to your account, but in Geemap, you can just one line of code, convert the shape file to Earth Engine object, and then you can use that to do all kind of analysis. It also allows you to load data layer from a local computer. So if you have some cloud optimized GeoTIFF, you have some vector data you want to overlay with Earth Engine data layer, but you don't want the data layer to be uploaded to Google Earth Engine. This also makes it possible. So it's a lot more flexible, and also you have IDE of your choice. You can use Jupyter Lab, you can use Visual Studio Code, you can use Python, whatever you like. And you can also access to all those AI tools, for example, GitHub Copilot, ChatGPT, whatever, right? Those plugins. Those are things that you won't have with a JavaScript code editor because it's limited to the browser. But this basically opens a whole lot more potentials, and then you can customize to whatever you want it to be look like, dark theme or light theme or whatever. And yeah, so I just want to show you kind of quickly go through how you get started. Again, the take-home message is that it's already on the Earth Engine documentation. It's really easy. All you need is just an account, and all you need is just know how to click the buttons. That's it. And then you can start exploring the data. You can source any data you like and load the data. So essentially now you have access to the entire data catalog, over 90 petabytes for free. And imagine that you can watch any movie that, like, for the past 100 years without paying anything. That would be fantastic. So the same thing here doing Geospatial now. All you need is to figure out how do I get access to the data. A couple lines of code, and then you can do whatever things you want. Okay, so that's all I want to share with you. So let's get back to the last slide.
Thanks, Qiusheng. That was really great. And also to give a thanks to all the contributors to Geemap. There's been over 40 people that have contributed code. It's a really active community. And Qiusheng has been amazing about issues that come up and bugs. He's on them sort of immediately. And we'd like to encourage people to get involved. So there's a link here for contributing. And on the various websites that Qiusheng showed, you'll find links to how you can contribute as well. And in particular, I wanted to thank Aaron Zuspan, who can't be here today, but he was the developer for EE-Repr.
Oh.
And so when you're printing an Earth Engine object in Python, typically you would have to do .getinfo, and you'd get a JSON structure back. And Aaron made a nice package to format that. He hides the getinfo, and you get a result that looks a lot like what you see in the code editor. Anyway, I wanted to special thanks for him.
Yeah, so contributions are all welcome. So you're welcome to check out the GitHub repository. And contribution means you report a bug, ask questions, submit a feature request, and then we will improve and get better. But if you are very good at like coding, you can look into the code base, you can improve. There are still a lot of things can be improved. You can contribute a new notebook or ask questions. So we'll try to get back to you if you have any questions within 24 hours. Free customer service. What else can you get? Any questions? We're happy to take any questions that you may have.
Well, I've got one question.
Okay.
When do you sleep?
Oh yeah,
Just kidding.
I was just sitting with Sam earlier. Like my free time, when I have free time, is to like do open source. That's when I relax and feel like rewarding because I've solved the problem and make it available people use. So my free time is from 9 p.m. to 12 a.m. or 1 a.m. Like when I have time to work on my open source project.
Yeah.
Yeah.
And as somebody that does support, you're a real inspiration. You get back to people so quickly. Thank you.
Yeah, I'm online all the time, so you can always, if you have any question, I'm happy to talk with you, or just email me, or Twitter, LinkedIn, whatever social media that you are using. Yeah.
Yeah. If anybody has questions, there's 2 microphones on either aisle there. Please just hop up and ask away.
Probably it's too easy, so no questions. It's no coding.
One line.
One line of code, yeah.
Is it working? Yeah. Thank you very much for everything you did for the Python community. I mean, without Geemap, that would be way more difficult to actually visualize anything. So yeah, big thanks first. While I was looking at your demonstration notebook, I noticed that something has changed since the last time I've updated Geemap. You're using CamelCase functions. So it's going to start technical, but then you will see it's a more general question. So you are using CamelCase functions, add layer with an underscore, meaning that you're overriding the IPY leaflet initial functions. And previously, you were actually re-overriding this function, I mean, linking it to something that was looking like the JavaScript code editor, add layer with a big L. Is there any reason why you actually stopped doing that? Because that was actually quite easy then to make just copy-paste from the JavaScript editor to the Python editor. And that's
yeah, good observation. So I didn't mention that. So previously, when I originally got started with Geemap, I want to make like seamless transition from JavaScript to Python. So when you see like in the past, create a map is like uppercase map equal to gmap.map, and now it's all lowercase because they're trying to follow the convention. Because, but the CamelCase is still supported. Like add uppercase layer is still supported. But from going forward, we will try to all the documentation we use the lowercase because we try to follow the convention. Otherwise, like those people don't know Google Earth Engine or Geospatial. But they're Python users. They look at the code like, oh, why do you like name a variable uppercase map? Like, it should be lowercase. Like map uppercase should be for CamelCase should be for class naming classes, something like that. So we're trying to for the core Geemap core. Now we follow the same convention: lowercase m and then what else? Snake case add layer. But it should not break the previous code. Everything should just work. So it has backward compatibility.
Okay. See, so if I can just jump on this one, I will open an issue, no worries.
Yeah.
But that was actually, for me at least, an insight that the function I was calling Earth Engine API. So anything that was looking Python was pure Python, and anything that was looking like the code editor was Earth Engine API. And as Earth Engine is now commercial, for people that are actually paying for it, it's very useful to have this kind of insight when you're calling a function before you're actually paying for it.
Yeah, yeah.
But again, that's I understand what you did.
Thank you.
Thank you very much.
Yeah.
I have a question about the process of like sharing the notebook after you've executed it. Can it save the rendered output so that somebody else opening my notebook that I want to share with pre-rendered output would be able to do that without authenticating and running Earth Engine?
Yeah, good question. So that one depends on the backend you are using. If you're using Podium, when you execute it, run it, and then you share it to other people, the map will still be available. But using IPy widget, IPy leaflet is not. So you when share with people, you just say map and then some text, so it's not available. But usually I would not recommend that you run the notebook and then save it and then share it to people because you are using the Earth Engine data layer. So that one actually is temporary. So I think it's 24 hours to 48 hours, something like that. So even if you can see the map, but within 24 hours, you'll be gone. So user cannot see the data layer. So what I would recommend is to follow the last demo I showed you, like interactive web app. So in that way, you share the link with other people. So when they go to, it's executing the code. So the Earth Engine data layer will always show up. Yeah. Thank you.
Hi, thank you so much for this presentation. My question is about, you mentioned the ability to plug into ArcGIS. And so I do a lot of using Arc to make finalized graphics. And when you would be able to display images from Google Earth Engine in Arc like that, would that purely just be as like a base map that you wouldn't be able to inspect individual pixels? And then my second question is there any sort of like resolution degradation that one should be aware of if they're adding Google Earth images into like an Esri something and they're going to export it?
Good question. The answer is no degradation is the same. Is that all the Earth engine data they will visualize essentially is just a Thai URL, XYZ URL. Okay. So it depends on your internet speed. It's pulling the data layer and then adding in ArcGIS or even QGIS as a basement data layer. So you cannot use that for doing analysis. But that's for now. But very soon you'll be able to do some analysis. But it's not like you're loading like gigabyte, terabyte. But if you're only like small area, I think we just released the XEE yesterday in the plenary. Alex, I'm not sure it's here. He developed the XEE. So that one allows you to pull that, convert the data to X-array or NumPy array, and then you can use it to do analysis. But that's something we want to work on in the future is to provide more analytical functionalities in those desktop. But I cannot guarantee when it will be implemented, but it's feasible because those new features they just released yesterday.
Okay, thank you.
Sure.
Hello. Thank you for all the awesome work and also the great presentation. One thing that I was wondering is with respect to the drawing ability on the map, is there a way that you could export what's being drawn? And
yes.
Follow-up question, is there a way that you could programmatically draw things where you could write code and then that code would put the objects onto the map and so you can see it that way?
Yes, it's both feasible. So if you draw anything, you can just map.user RI, user underscore RI. I can show you later, like offline. You can get the object, or you can user RIS. You get the feature collection, and then if you want to save the object, you just like Gmap. What's that? E to GeoJSON, E to SHP. You can save to whatever vector data format you want. So basically, it's just one line of code. And what's your the other
if you
question?
could programmatically draw.
Oh yes. So programmatically, basically you're creating Earth engine object. So it's the same as like geometry, passing whatever coordinates you want, or bounding box, or a polygon. You can do that. But if you're talking about like the draw control, yeah, it's also possible. You can edit the IPy widget like draw control, the data attribute. I can also show you. So those are more like low level, but yeah, the short answer is yeah, both are feasible.
Got it. Awesome. Thank you.
How about from this side? This it's all good, no question.
All right. Well, thank you, everybody.
Yeah. Thank you for your attention. Yeah.